All right, so we're going to review our inequalities in triangles because y'all didn't do so well on that on your last test. So I'm going to include it on your next test so everyone will be retaking this objective. So we're going to review the corollary to the remote exterior angle theorem, the triangle inequality theorem, and the Hinge theorem. So remember that the remote exterior angle theorem says that the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. Okay. Its corollary says that the measure of an exterior angle of the triangle is greater than the measure of each of the remote interior angle. So basically this says that the measure of angle 3 is greater than the measure of angle 1, and the measure of angle 3 is greater than the measure of angle 2, which makes sense because if they're equal, then they're, if when you add these, they're equal, then this can't be the same as 3. This can't be the same as 3, okay? And they can't be more than 3 because then it would not be equal. If the measure of angle 1 was greater than the measure of angle 3, then the measure of angle 1 plus the measure of angle 2 would be greater than the measure of angle 3. So why is the measure of angle 1 greater than the measure of angle 4? Well, by that corollary, we know that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay. We also know that angle 3 and angle 4 are congruent, so we know that. So their measures are equal. Okay. So if we know that to be true, then we can substitute in and we can say that the measure of angle 2 plus the measure of angle 4 is equal to the measure of angle 1. Okay. And by that last theorem, we know that the measure of angle 1 then has to be greater than the measure of angle 2, and it would have to be greater than the measure of angle 4. So by that corollary to the remote exterior angle theorem, the measure of angle 1 has to be greater than the measure of angle 4. Right, so if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. And if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. You guys did really well on this part of the test, but just to review, if I know that this is 12, this is 10, and this is 7, and I have angle PSU, okay, my smallest side is 7, so my smallest angle is going to be angle U, and it's going to be less than the middle angle, which would be opposite this, P. We would actually say the measure of angle U is less than the measure of angle P, which is less than the measure of angle S. So if I listed them in order from smallest to least, the angle U, angle P, and angle S. Okay, but you guys did well on that. I'm not worried about those two. Now, the triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So, example, which of the following sets of numbers can be sides of a triangle? So my two smallest sides have to be larger when I add them together than the third. So 6 plus 12 equals 18. Okay, and 18 is not bigger than the third side, which is 18. So this is not a triangle. So remember on the board in class, I talked about it falling in on itself, so it's not a triangle. Here, 11 plus 16 is 27, and again, that's not greater than our longest side. So that's not a triangle. Here, my two smallest sides are my 5 and my 7. So 5 plus 7 is 12. 12 is greater than 9, the third side. So yes, this is a triangle. Okay. So if the two sides of a triangle, we're going to continue with this theorem. Two sides of a triangle are 11 and 16. Which of the following can be, ooh, bad grammar, good thing I teach math, the length of the third? Right. So if these are my two smallest sides, then they have to be bigger than the third side. Okay. The sum of them. So the third side has to be less than 27. Okay, so that's going to leave out 29. But if these are the two largest sides, then the smallest side has to be greater than 5, because 5 plus 11 is 16. So my sides have to be between 5 and 27. So it's going to leave out 4 and 5 and 27, and it's just going to be 10. So does that make sense? If these are my largest sides, my two smallest sides, sorry, they have to be, when I add them together, greater than 27. If they're my two largest sides, then I'm going to subtract them, because 11 and 5 is 16. And it has to be, the sum of those has to be greater than 16. So anything between 5 and 27 would work for the length of the third side. We also have the Hinge theorem. And the Hinge theorem says that if two sides of one triangle are congruent to two sides of another triangle, and the included sides are not congruent, angles are not congruent, then the longer third side is opposite the larger included angle. And this was the Hinge theorem. Remember, I stood by the door and explained that as I close the door, the side opposite the door gets smaller and smaller, but the two sides stay the same. So in this case, I've got RS congruent to AB, and I've got TS congruent to CB. Okay. But my angles are different. This is 90 degrees and this is 98 degrees. So that means that AC is going to be greater than RT. That's my bigger angle. So that's what I'm looking for. AC greater than RT. Okay. So what is my range of possible values for X? Well, I know first of all, this angle can't be 0. So I'm going to take care of that right away. So 0, so 4x minus 8 has to be greater than 0. So 4x is greater than 8, and x has to be greater than 2. Then I know that these are congruent. So this side and this side, and this side and this side are congruent. If I was to draw perpendicular here, okay, this angle is definitely smaller than 90 degrees. So my other equation is going to be 4x minus 8 has got to be less than 90 degrees. So 4x is less than 98. X is less than 98 divided by 4. 24.5. Okay. So now my range is my x has got to be between 2 and 24.5. So there is my solution for my range. There was a question like that in the test, and most of you guys got that wrong. All right. Again, using the Hinge theorem, which side is the shortest side? So I need to know what the angles of my triangles are. So in triangle BCD, I've already got 45 plus 92 is 137. And 180 minus that is 43. So this is 43. Okay. In this triangle over here with 68 plus 57, that's 125. And 180 minus that is 55. All right. Now I know that these sides that are congruent are marked congruent. I know that in this triangle here, this is going to be my shortest side. And this triangle here, this will be my shortest side. And those are actually congruent. So in this case, BD and CE are going to be the two shortest sides. They're going to be tied for the shortest side. Okay. If I wanted to know the largest side, I know that in this triangle, this is the largest side. So here is the largest. In the green triangle, this is my largest side. Okay. With this and this being congruent, so we know that and this is congruent to itself, 92 is bigger than 55. So we know that this, well, actually, we want to know if this is the longest side. We know that this is 92 and this is 68. Okay. And 92 is bigger than 68. So BC would be our largest side. Okay. So we went over a lot of theorems today. This is review. This will be on your next test. So have a math-tastic day.